In this video, we are going to start talking about logarithmic functions. So a logarithmic function looks like this. F of x equals log base b of x. Okay, and we say that this is the logarithmic function with base b. You can also write it as y equals log base b of x here. And what we know is that y equals log base b of x is equivalent to saying b to the y power equals x. Now there are some restrictions here, namely that x has to be greater than 0, b has to be greater than 0, and b can't be 1. And if you look here, b is our base in this exponential equation. And we remember we said last time that b couldn't be 1 because 1 to the any power is just 1, so that doesn't help us. So if you look at this example here, 3 equals log base 7 of 343, this is equivalent to saying 7, that's our b base, to the third power, that's our y, is equal to 343, which is our x. Okay, so we're going to work with changing from a logarithmic function into an exponential function. Okay, so if I give you this one here that says 5 equals log base 3 of 243, what I want you to do is rewrite it in exponential form. So we take our log base, which is 3, we raise it to the power over here. What our answer here is going to become our power, so 3 to the 5 power, and that equals our x, which is what we were taking the log of. Okay. Similarly here, we're saying take your base, which is b in this case, raise it to whatever our log is equivalent to, or is equal to, and then that equals our x value, which would be here. So b to the 5th power equals 49. So essentially you will be asked at times to take a logarithmic equation and just rewrite it in exponential form. Similarly, you will be given an exponential equation and you will be asked to write it in logarithmic form. Okay, so in order to do this, we say log, this base here becomes our base for our log, so log base 13. Notice that log base is down lower, and typically it's a little bit smaller, so a little hard for me to do on this system, but you get the idea and give it a good try. So log base 13, our x value that goes in our log here is this 2,197, and then that equals our y value, which is our exponent here on the exponential. Similarly here, I'm going to say this is log base y of 200, not 2,000, oops, got a little carried away with my zeros there, and that equals 4. So you will have several times in your homework problems where you're going to be asked to go back and forth, either from a log to an exponential or from an exponential to a log. Now being able to do that is really important, okay, because it can help us when we are evaluating. So since we know how to think about exponentials and logs together, we can evaluate some different logs without using a calculator. And we say without using a calculator because there's no way for you to plug log base 2 into your calculator, or log base 16. You may see a log button, and we'll talk about that later, but you can't do log base 2 in your calculator. Okay? So what we're saying is, what does this equal? We don't know. Well, if I rewrite it in my exponential form, 2 to the question mark equals 8, then what I'm really saying is, well, 2 to the what power equals 8? That's 3, right? So this equals 3. Similarly here, I don't know what this is equal to, so I'm saying 16 to the what power equals 4. Okay, well, I'm thinking to myself, how am I going to change this so that I can figure out what this value is? Well, okay, let's rewrite this so that they're the same log bases, or they're the same bases. 16 I know is 4 squared, right? So I just took the 16, I wrote it as 4 squared, and that's to the question mark. And this is 4, which is 4 to the 1. Okay. Well, when I raise a power to a power, I multiply here. So what I have is 4 to the 2 times my question mark. You could use an x if you wanted. So 2 question marks equals 4 to the 1. So 2 question marks equals 1. So what does question mark equal? Well, it's going to be 1/2. Similarly here, 7 to the what power equals 49. We know that this is 2. And on this last one, 15 to the what power equals 1. Well, how do we get 1? That's right, anything to the 0 power is 1, so this is 0. So there are some basic properties of logarithms that the book is laying out for us here. And basically we're saying if you take log base b of b, it's always going to equal 1. Or if you take log base b of 1, it's always going to equal 0. This is no matter what your b values are, except for remember b cannot equal 1, and it has to be a positive number. Similarly, if you take log base b of b to the x, well, the log base b of b, those parts cancel, and we're left with just the x. Or if you're going to do an exponential of b to the log base b of x, you still end up with just x on that one. Okay? So let's evaluate these. Log base 11 of 11 squared, well, that looks like this one here, right? Log base b of b to the x. So what should this equal? It should equal 2. Log base 3 of 1, that looks like this one here. Log base b of 1, that equals 0. Log base 8 of 8, well, that one looks like this here. Log base b of b, so this must be 1. And here I'm taking 5 to the log base 5 of 19. That looks like this one here. So in this case, x was the 19, so it's going to equal x, or it equals 19. All right, that's a good start to logarithms. We'll see you in the next video.